In this lesson, we shall look at this question 3 in the diagram. S with coordinates 0 and minus 16. Here is S with those coordinates, and L and Q with the coordinates 4 and minus 8 are the vertices of triangle SLQ. SLQ. Having LQ perpendicular to SQ, LQ is clearly perpendicular to S, their Q. Okay. SL and SQ are produced to points R and M respectively. Right. So let's look at the fact that SL and SQ are produced to points R and M respectively. So you can see that SL is produced to R, but also SQ is produced to M, such that RM is parallel to LQ. RM is parallel to LQ. SM produced cuts the x-axis at N, which has coordinates 8 and 0. Right, so we have the N with those coordinates. QM is equal to MN. Right, so you have that QM is equal to MN. So if you have QM is equal to MN, T and P are the T and P are the y-intercepts of RM and LQ respectively. So you have actually your coordinates here, T and P are the y-intercepts of RM and LQ respectively. Okay, now calculate the coordinates of M. We need the coordinates of M. And obviously we can see that now we have been told about M, that at this point, what you have, therefore, that M, as it is sitting here, it is actually a midpoint, right? So SM produced cast the x-axis at N with those coordinates, but QM is equal to MN, right? So QM is equal to MN. Because QM is equal to MN, it means we can find the coordinates of M, and we find the coordinates of M as follows. Right, so we're going to use what we call the midpoint formula. So we look at 3.1, and to look at 3.1, we use what we call the midpoint. Right, we use the midpoint formula. What is the midpoint formula? The midpoint formula is x1 plus x2 out of 2, y1 plus y2 out of 2. Right, so if you look at M here, so this is x1, y1, and this is x2, y2. So that x1 is 4, and x2 is 8 out of 2, and y1 is minus 8, and then y2 is 0. y2 is 0 out of 2, and you actually simplify this, and 4 plus 8, we know that it's 12 out of 2, and we have minus 8 out of 2, and therefore this is a 6 and this is a minus 4, like this. And this means therefore the coordinates of M, we write that M has the coordinates 6 and minus 4, like that. So we're to find the coordinates of M, but also, I mean, we have been told that QM is equal to MN. Okay, so now that is something that is very important. Right, so we found the coordinates of M. And the next question is, right, the next question is, we are interested in finding, in calculating the gradient of a, right, we're interested in, right, in calculating the gradient, but the gradient of NS. Right, so this is N, and that is, this is exactly N, and that is S, and we want to find the gradient. So in this question, the examiner is asking for the concept of what we call the gradient. What is a gradient? Right, so we discuss what a gradient is. So the examiner will often use the words gradient or slope. And the gradient is change in Y, change in x, so that at this point, to find the gradient of ns, you have that this is x1, y1, and this is actually x2, y2. So to find the gradient of the line ns, you write m and s. Right, so to actually signify, so the gradient is actually represented by m there. Okay, right, than any letter G, especially in the English context. In which case, therefore, the change in y would therefore become a y2 minus a y1 over x2 minus x1. Right, to find the gradient of ns, you have y2, which is minus 16, minus y1, which is 0, divided by x2, which is 0, and x1 is minus 8. So that in the end, then you have minus 16 divided by minus 8, and the result is a 2. And at this point, we are able to see that normally, obviously, we use the lowercase symbol so that we can say the gradient of ns is actually equal to 2, like that. So just take note of that because this is very, very important for us. Okay, now in 3.3, we are interested in show that the equation of the line LQ is minus 1/2 x minus 6. So we're interested in finding the equation of the line LQ. Right. Now, what is the gradient of the line LQ? Who can tell us what is the gradient of the line LQ and how do you find the gradient of LQ? Quickly. Right, so to find the answer to 3.3, we want to find the equation of the line LQ. We note that we know the gradient of the line NS. Right, so the gradient of NS we know very well is 2. So that the gradient of LQ times the gradient of NS is minus 1. Why? Because LQ is perpendicular to NS, like this. Okay, because if the two lines LQ, right, LQ is perpendicular to NS, right? So if two lines are perpendicular, then if you multiply their gradients, the result is minus 1. What is the gradient of NS? Right, we have already got the gradient of NS from this question, and we got it to be 2 in the previous question, so that you put the 2 here. And this means that the gradient of LQ times 2 is minus 1. Okay, and at this point, if you have the gradient of LQ times 2, you divide the left by 2, and we have minus 1 divided by 2, so that we have the gradient of LQ is minus 1/2. And at this point, we're interested in finding the equation of the line LQ. But the line LQ passes through, so you write through like this, right? It passes through the point Q with the coordinates 4 and minus 8. 4 and minus 8, like this. Right, so at this point, we're able to see that we have the following. Okay, the formula is y minus y1 to find the equation of a line through a point. Is m into x minus x1. Right, so it is m into x minus x1. So that what you have is y minus. At the point Q, you have x1, y1. So that you have y1 is minus 8. The gradient of the line LQ is minus 1/2 into x minus x1. X1 is a 4, which is minus 1/2 x plus 2 minus 8. So this is minus 1/2 x minus 6, and this is the answer. Right, you can write that clearly, for example. Okay, you can write that clearly and say, what you then have is that y is equal to Right, y is equal to minus 1/2 x minus 6. And this is actually the, right, it is the gradient. It is rather the equation of this line. By the way, it was already given with just to show, and we're able to show indeed that the equation of the line LQ is this one. We got the answer the examiner expected us to get, because they said the students to show that y is minus 1/2 x minus 6, and it is y equals minus 1/2 x minus 6. Right, so we actually have been able to solve the question 3.3 there. This section we're looking at right now is called analytical geometry. Next point. Determine the equation of a circle having center O, the origin, and also passing through S. Want to find the equation of a circle having center O, the origin, and also passing through, right, passing through the point S. So there is a circle that is going to have center, yeah. Okay, this is not going to be to scale, but you'll have a situation where this circle has the center, the origin, and passes through the point S like that. So yeah, this is second like this. But obviously, since it passes through the point S, we're going to be in a position to do this with ease. So now the equation of a circle in 3.4 is to say x minus the coordinate of the center, y minus b is the r squared. So it passes through the origin, the center is 0 and 0, a and b. X minus 0 squared, y minus that squared is r squared. Okay, which means therefore it is x squared plus y squared is r squared. Okay, but it passes through the point. So the circle passes through. Right, so it passes through S with 0 and minus 16. And the S gives us the coordinates of x and y, so that you have the x here, which is 0 squared, and the y is minus 16 squared. And this is r squared. Okay. So this means that r squared is equal to, what is r squared equal to? 16 by 16, which is actually 16 squared. And what is 16 squared? Okay, let us check that part. Is 256. So that then in the end, what we have is that your x squared plus y squared is r squared. X squared plus y squared is r squared, and r squared is 256. The equation of the circle is x squared plus y squared is equal to 256, and therefore it is the equation of the circle with center, the origin, center at O. Okay, so please, these things here, I'm gonna send you the homework that you need to try on these things on the WhatsApp group, and you're gonna try the homework and make sure that you understand. Now, first, before you try the homeworks, you need to watch the videos. You don't just try the homework, because you're not gonna find it easy. You're gonna find it difficult. But first things first, you need to make sure that you first watch the video. But when you watch the videos, you don't watch the whole video. You just watch one question and then see if you understand that, and then you try the question on your own without looking at the answer to see if you're able to follow until you solve all the problems. The next question. Right, we're interested in calculating the coordinates of t. Right, we want the coordinates of t, and here is t. The question, what are the coordinates of t that is sitting there? What are the coordinates of this? Obviously, I mean, this is very, very easy. To find the coordinates of t, it's straightforward. Let us find the coordinate of t. Right, now, the fact that this line is parallel to this, it means therefore we know that in 3.5 that we need to do the gradient. Right, the gradient of Rm must be the gradient of LQ. The gradient of Rm must be gradient of LQ, which is minus 1/2. We already know that the gradient of LQ is minus 1/2. We got it here. The equation of the line LQ. Because if the equation of the line is like this signifies that you are dealing with y equals mx plus c. So that in the end, then what we have here is the gradient of the line Rm. Right, so the gradient of the line Rm is actually equal to this. Okay, parallel lines have equal gradients. Okay, so if parallel lines have equal gradients, what you then have is that Rm, the gradient of Rm is equal to gradient of LQ, which is minus 1/2. The reason is that Rm is parallel to LQ, like this. Okay, parallel lines have equal gradients. If two lines are parallel like the Rm and the LQ, here is R and here is M, here is L and here is Q. These are parallel lines. So it means the gradient of the line Rm is equal to the gradient of the line LQ. Why? Because they're parallel to each other. Okay, parallel lines have equal gradients, guys. That's a very important property. Okay, we're using that because now I want to find the coordinates of the line, the coordinates of t, of the point t. Right, to find the coordinates of t, a couple of things that are very important. First things first, we need to find the equation of the line that contains the point t. How do you find the equation of the line? It passes through m. Right, we have the gradient of this, but this line that passes through t also passes through m. So it passes through m. What are the coordinates of m? Right, the coordinates of m are 6 and minus 4, which means therefore you have x1, y1, which means you have y minus y1, which is equal to m into x minus x1, which is y minus, right, minus 4, which equals minus 1/2 into x minus, the x1 itself is 6. So that you have y plus 4 equals minus 1/2 6, minus 1/2 x plus 3, which means that minus 1/2 x minus 1, like this. Okay. So let us look at these together. So yeah, it means therefore the equation of the line, of this line here through t, is this line has the equation, this one here. And because of this, you need to therefore now use the equation of this line to find the y-intercept, because this t is a white cut. It's a white cut, and this white cut is called the y-intercept. Okay, how do you find the coordinates of a y-intercept? So you want to find a y-intercept, a point where the line cuts the y-axis. So to do that, you let x be equal to 0. To find the y-intercept, you let x be equal to 0 in the equation, so that you have minus 1/2, 0, minus 1. And minus 1/2, 0 is 0, minus 1 is equal to minus 1. As a consequence, it means the coordinates of t is on the y-axis. Automatically, it means x is 0, right? X is 0 and y is minus 1, like this. X is 0 and y is minus 1. So now we therefore need to calculate the coordinates of t, which are 0 and minus 1. 0 and minus 1. Okay. Right, so we continue to look at other things. Right. Now we also need to actually now determine. Okay, we found that the coordinates of t are that, so you can even come here and say the coordinates of t are 0 and minus 1. 0 and minus 1. So in 3.6, you have to determine LS to RS. LS to RS. Right. LS to RS. So that in the end, what we then have is that we need to find this. And to find this, we proceed as follows. So to determine LS to RS, right, LS to RS, we proceed as follows. First things first, we have the following thing. We do not know quite the coordinates of R, the coordinates of L, the coordinates of S, but we actually know some of the coordinates. Like we know the coordinates of T, we found them to be 0 together with -1. We found the coordinates of P to be 0 with -6, like this. Right, so we continue. Right, so we continue. We continue to solve this one, please. Okay, try the question, please. We're doing 3.6. Try the question and we shall... Right, try the question, right, and then we shall do it together now. And then you tell me the answer to 3.6. You need to find LS divided by RS. You need to find LS over... These are like distances. The distance from L to S. The distance from L to S. So we continue. All right, we continue. Right. We continue. Right. Okay, let's see. Right. See now. Yes. All right. Yeah, I'm swinging to another student. I want to see if they... Yeah. Okay. In the meantime. Right. Okay. Yeah. We continue. I'm wondering why another student is saying, okay, yeah, try the question, please. I'm trying to see why this other student is saying is battling to join. Wondering. Um, okay. Let's see now. Okay, I'm trying to see why another student is battling to join. Right. Okay. Okay. Yeah, let's try. Okay, let us do this question here. So we want to right. So you have T, that is coordinate 0, -1. Okay. Right. Pegalelo, yeah, welcome, welcome. Yeah, I was trying to see why is it that you were battling to join the meeting, but I'm happy that I can see that you have joined now. Are we together, Pegalelo? Hello, Pegalelo.
Yes, sir.
All right, welcome. Yeah, okay. I was wondering why you couldn't join. I'm so sorry. Yeah, welcome, welcome. I was worried that you could not join the meeting. So I was very worried. But I'm happy that at least now finally you're able to join. Please, if it can always be these network issues, but once again, from the coming weekend, I'm gonna be using two platforms. I'm gonna be using Microsoft Teams as well, MS Teams. It is my hope, therefore, that we shall have an excellent connection then. Just in case you can't use the Zoom or the Zoom is giving problems, we're going to use Microsoft Teams. I'm going to be briefing you during the course of the week because whenever we have like sporadic discussions during the course of the week that we are planning that we have. Okay, now we want to determine LS over RS. So we want to determine LS over RS. Right. And so the question is, what then do we do here? Right. So to do that, we first note that LS over RS. Right. So you have LS over RS is equal to, now if you look at the LS, is equal to, it's going to be associated with what? Right. If you look at the LS, what will it be associated with? Right. So you need to look at this and think very carefully. It's going to be associated with PS. Right. So the LS of RS is going to be associated with PS. And then now the RS is going to be associated with TS. Okay. So that now it's easy to calculate the distances here because the distance on the y-axis, like what is the distance between -6 and -1 when the both x coordinates are 0? The distance between -1 and -6 is exactly what? Right, that is going to give us the PS, or rather the the PT. And also now, if you want to find the whole of PS, what is the distance between -6 and -16 when both x coordinates are 0? We're looking at the PS here, and therefore the distance between -6 and -16 is actually 10. So you can then say the distance is minus this um, plus. So you subtract these things, you can do it like this, but you subtract them in a way that is going to produce a positive. So you don't subtract them in a way that is going to produce a negative. Okay, so the distance between -6 and -16, you subtract them like this. Look at the fact that negative times negative is going to give us a positive, so that in the end we have a positive number. The larger number is positive. But now the TS, right, so that is PS, and then you're looking at the TS. TS itself is the distance between, right, is the distance between -1 and -16. So which means you have -1 minus into -16, and this is -6 plus 16 divided by -1 plus 16. And this is exactly 10 over 15. And 10 over 15 is what? 5 goes how many times? It goes 2 times and goes 3 times there. So, and this actually allows us to therefore say, as a consequence, therefore, LS over RS is equal to PS over TS, and this is 2 out of 3. The LS over RS is just 2 out of 3, and we've just found that. Think of this and make sure that these make sense to you. But also, this is critically important for us to be in a position to decipher these and make the most of this here. Next thing is we're looking at 3.7. 3.7. In 3.7, you want to calculate the area of PTMQ. Right, so you have PTMQ. We have to find the area of this shape here. What do we call this shape here? That is two sides parallel. There's a shape that you can draw like this. A shape like this. What do you call this shape that has two parallel sides like this? And then obviously, yeah, what do you call this shape? It's called a trapezium. Right, so in other words, we're looking at a trapezium and we want to find the area of what you call a trapezium. How do you find the area of a trapezium? You find the area of a trapezium by looking at the fact that you have the area of, right, so you have the area of PTMQ. And the area of PTMQ is the area of triangle TSM minus the area of triangle PSQ. Okay, let's continue. So the area of triangle TSM, the area of, yeah. So now to find the area of PTMQ, we can just find the area of triangle TSM. So you're going to find the area of triangle TSM. And this area of triangle TSM is half the base. So it's half the base, which is ST, times the perpendicular height, right through M, minus half the base of the triangle PSQ. Right, just look at the triangle PSQ. So you say half the base PS times the perpendicular height HQ. And therefore you have half the base ST. Right, so now in the end then we have half the base ST. Right, so what is the base ST? Right, to find the area of the base ST, now you know that T has the coordinates 0 together with -1. Remember that we just found in the previous question. P has the coordinates 0, -6. Right, so at this point, if you have the you want to find the area here. So the ST, what is the distance between S and T? -16 and -1, the distance is 15. Can you imagine 16 minus 1 is like a 15. So that now ST is like 15 units because this is like on the vertical axis, on the y-axis. And therefore, you also have to look at that one there. And then now you have the perpendicular height through M. So in other words, if you have half the base ST and the perpendicular height through M, right, and the perpendicular height through M, you know very well that M has those coordinates. We found the coordinates of M. What did we get the coordinates of M to be? Okay, so the coordinates of M, I'm just going to write them here. We got them earlier, but the coordinates of M are exactly 6 together with -4. So that now you have the perpendicular height through M here, and the perpendicular height is actually how much on the x-axis one migrates horizontally, and the perpendicular height is exactly 6. It's exactly 6 minus half the base. Now you have half the triangle PS. Right. So now if you have the area of the triangle PSQ, right, looking at the PSQ, you have half the base, the PS. And what is the distance between P and S? The distance between -6 and -16 is 10. The height is this one. Okay. On the X, Y, so yeah. And therefore it's only 4, like that. Okay, so now we look at this as 45 minus 20. 45 minus 20 is 25 square units. 25 square units. Right, so we have to find the area of PTMQ. So we can come here and therefore say, therefore the area, right, area, you can write also like this. Doesn't matter, you don't need to write capitals. You can write small letters as follows and say, for example, you can come and say area, right, area of trapezium. Right, trapezium PTMQ, and this area is 25 square units. 25 square units. That is the area of PTMQ, like that. And then a couple of things that obviously we're gonna take into account. Okay, so yeah, that is the area of trapezium, PTMQ, which is actually 25 square units there. Next question. The next question is about circles. Now, question 4 in the diagram, P has the coordinates -3 and 4 is the center of the circle. So you have a circle like this with a center. V has the coordinates K and 1. Right, W are the endpoints of a diameter. So you have that V and W are the endpoints of a diameter. Okay, here's the diameter and then the endpoints of V and W there. The circle intersects the y-axis at B and C. B and C are the points of intersection of this circle with the y-axis. BCVW is a cyclic quadrilateral. So you have BCVW is a cyclic quadrilateral. CV is produced to intersect the x-axis at T, right, at T there. Right, the angle OTC is alpha. Here's the angle alpha. The angle alpha is actually angle OTC. Okay, and then now we're asking the question, and we're saying the radius of the circle is the square root of 10. So the examiner gave us the radius of the circle, and they said the radius of the circle is the square root of 10. If the radius of the circle is the square root of 10, here's the circle, its radius is the square root of 10. And then now you need to find, calculate the value of K if V is to the right of point P. If V is to the right of point P, calculate the value of K. Let us look at this particular question. So obviously, if the radius of the circle is the square root of 10, so the distance from the center of the circumference is the square root of 10. That means that PV is R, which is the square root of 10. PV. Okay, you have P and the V. So we want to find the distance. Right, so to find the distance between P and V, use the distance formula that says x2 minus x1 squared, y2 minus y1 squared. This is called the distance formula. this is called the distance formula. And you already know that the radius of this circle is the square root of 10 units, square root of 10 units. All right, so it is square root of 10. This PV is the square root of 10 units. Now, what do you do here? You take this into account and we perform substitution. We are dealing with P and V. Right, so P and V, P has x1, y1, V has x2, y2, which means that at this point, what you have here is x2, for example, and x2 is k minus x1. x1 is minus 3. You square this. What is y2? y2 is 1 minus y1. y1 is a 4, and you square this. And this is the square root of 10. And you square both sides of this. Right, after you've written this, what you do is you square both sides of this equation, getting a 10, and then here you have a k plus 3, you square it, and then this is a 9. Okay, k plus 3, you square this, is equal to 10 minus 9. What is 10 minus 9? 10 minus 9 is a 1. You take the square root of k plus 3. You square both sides. You square root both sides. You see, if you square root both sides, what then are you able to achieve? Right, when you square root both sides, you put a plus or minus the square root of 1. Okay, so that you have k plus 3, which is plus or minus 1. Now, it means that you have k plus 3. Okay, let me write a little bit up here, this one. Right, so at this point, what you have here is that this one can be put here, so that you have k plus 3 equals plus or minus 1, because the square root of 1 is 1. And therefore, you have k plus 3 is 1, or k plus 3 is minus 1, which means k is minus 2. Right, which means k is minus 2, or k is a minus 4. Take this very carefully and see that you understand what is happening here as a matter of fact, because this is what we have, and this is what you need to have. So, but now there are two values of k, but we need one of them. And now the examiner said calculate the value of k, right, if value of k if point V is to the right of the point P. If it is to the right, because now these values of k, V has the coordinates. V has the coordinates k and 1. So if it is to the right, what does it mean to the right? It means, therefore, because the x value, this is x and y, k is an x value of v. If it is to the right, it means, therefore, the x is bigger than the x at p, because v is to the right of p. If x is minus 3 here, x must be bigger because x is increasing to the right. So now x is minus 3 at p, so you must choose a minus 2 there. So it means, therefore, that you must conclude here that k equals minus 2 here. K equals minus 2 there. Then now we look at the next question. It's 4.2. The equation of the circle is given as this. Calculate the length of BC. The equation of this circle is given. You need to find the length of BC. And to find the length of BC, these are just the intercepts with the y-axis, and these are the y-intercepts. So we look at 4.2. Right, so to deal with 4.2, we will attempt to calculate the length of BC. Right, to find the length of BC, there are a couple of things that we need to consider. So we have x squared plus 6x plus y squared minus 8y plus 15, and the result is 0. And we're interested in the y-intercepts. Right, so we're interested in the y-intercepts. Okay, so to find the y-intercept, so obviously these are two y-intercepts and these are distinct. So you can actually, obviously, I mean, with confidence say these are y-intercepts. How do you get the y-intercepts? To get y-intercepts, you let x be 0. Okay, these questions, I'm going to send you a homework, a home activity. You try this home activity. And now I'm going to impose a rule of submission of the home activity because some of you guys, I have a feeling that I know some students get lazy and they don't do the work. And they don't do these home activities. The home activities are not decorations. They're not ornaments. So this is y squared minus 8y plus 15, and the result is 0. So yeah, this is y squared minus 8y plus 15 equals 0. You can find the factors of this. The factors of this are y minus 5 and y minus 3 equals 0, so that y is 5 or y is 3, like this. Okay, so obviously, if you look at the B is above. So y is 5 at the B and y is 3 at the C. So now the equation, we have that. Calculate the length of BC. And therefore, that BC will be the difference between 5 and 3. So now you can then say BC is like 5 minus 3, and 5 minus 3 is 2 units. 5 minus 3 is actually 2 units, so that the length of BC is actually 2 units there. Next, we continue to do extra calculations, like if k is minus 2, calculate the size of the angle alpha. Right, if k is minus 2, we need the size of the angle alpha, and therefore we can easily be in a position to find the size of the angle alpha. And therefore we just okay, yeah, we apologize there if you get disconnected. The disconnection might be always caused by a network issue, I believe, and therefore we obviously need to apologize in the event of such an interruption there. All right, so what then do we do here at this point? If k is minus 2, calculate the size of the angle alpha. Right, so let's do this one. Right, so here they said k is minus 2. So in other words, you have this diagram here like this, and they have the angle alpha, and you have that this is minus 2 and 1, so that you need to find the actual size of alpha. To find the size of alpha, what then do we do here? Right, we can be in a position to do that with ease, and we proceed as follows. Right, we can just find the gradient of the line TC, all right? And how to find the gradient of the line TC? We know this one here, we have already found the coordinates to be sort of 0 and 3. Yes, right. So we already found the coordinates because we did this here, it was 3, 5, 3. So in other words, if this is 5, 3, okay, it means therefore x is 0 and y is 3 there. And then obviously at the v, you have v as this coordinates. So we can be in a position to find the gradient. So this one is x1, y1. This one is x2, y2. We continue to solve this problem, but we solve this problem in a step-by-step manner, right? And we solve it as follows, right? What then do? We do the following. So we're going to find the gradient. We're going to find the gradient of TC. Change in y, change in x. y2 minus y1, x2 minus xy. What is y2? y1 is 3. x2 is minus 2. x1 is 0. Minus 2 is 1. So that now the tangent of the angle alpha is the gradient, TC, which is 1. Okay, to find the angles here, we use the tangent. So prepare for the exam because these are the things you're going to meet. So the tangent of alpha here is the equal to the gradient of TC. And therefore, we have that tangent alpha is 1. Okay, so now if you use the calculator, you do the shift. You do shift so that it is arctan 1, and arctan 1 is 45 degrees. So that the angle alpha here is actually equal to 45 degrees. The angle alpha is 45 degrees. Then next to calculate the size of the angle VWB. VWB. We want the size of this angle here. What is the size of this angle over there? Right, obviously this angle is way too easy, and we can be able to determine that just using a couple of things. But what do we know exactly about this angle here? Right, the couple of things, like the angle, let's look at this one very carefully. You already know that this angle is 45 degrees. If this angle is 45 degrees, what is the size of this angle VWB? Right, here is VWB. What is the size of this angle? We can find the size of that angle as long as we're able to reason, but to reason very appropriately. But how so are we able to reason very appropriately? Right, there are a couple of things that we need to take into account to be able to find the size of that angle. But first things first, we note that the angle, there's an angle BCV. Angle BCV. What is the size of this angle here? Right, the size of the angle BCV, this angle there. What is the size of this angle? Because if you already know that this angle is 45 degrees, this one is using grade 10 geometry. What is grade 10 geometry? In grade 10, you were taught something at grade 10. You were taught at grade 10 that the exterior angle of a triangle is equal to the sum of the interior opposite angles. So if you have this here, this is that. So you're able to see that angle C1 is A plus angle B. Why is this? Because the exterior angle of triangle. Right, we say that. So the exterior angle of triangle is called the sum of the interior opposite angles. So if you look at these here, it does this, and it does this, and it does this. So this is like an exterior angle, so that the angle BCV is equal to the sum of the interior opposite angles. So we have the 45 degrees with the 90 there. We have the 45 degrees with the 90, so that in the end, then 45 degrees plus 90 in this diagram. So this one is equal to this plus this. So it is 45 degrees plus 90 degrees, which is equal to what? 135 degrees. Good, we are here. Okay, and the reason for this is exterior angle of triangle. Exterior angle of triangle. So that in the end, now, I mean, if this one is 135 degrees, what is then the size of the angle that is wanted? What is the size of the angle that obviously the examiner wants? Because the examiner wants the size of the other angle. They want VWB. Let us check VWB. Right, so if you check VWB, what is the size of that angle there? Okay, this one is a cyclic quadrilateral. So in a cyclic quadrilateral at grade 11, we are taught, and we need to learn this because it's grade 11 and technically metric as well. Somebody says that. So we have A, B, C, D. If this is a cyclic quadrilateral, the opposite angles are supplementary, so that the angle A plus the angle C is 180 degrees. Why is this the case? These are opposite angles of cyclic quad. Okay, opposite angles of cyclic quad. What do we know about the opposite angles of a cyclic quad? they add up to 180 degrees. They're supplementary angles. So now if they're supplementary angles, we're able to then say at this point, we actually can take this forward and then say we're interested in VWB. So VWB, this one. So if in this here, this plus 135 must be 180 degrees. So in other words, we're able to see that the angle VWB is actually equal to 45 degrees because it is, if this is 45 degrees, 45 plus 135 is 180 degrees. Right. So in other words, you can even say, let's do this. You can say the VWB is equal to, so because everything is 180 degrees, if you add them up and then you subtract, you want to get VWB, this one. So you say 180 minus 135 degrees, and this is 45 degrees. Why is this the case? Why is it that when you add this plus this, you get 180? Why? Because these are opposite angles of cyclic quad, okay? So now this is very important. Opposite angles of cyclic quad. Right, so that the angle VWB like this is actually equal to 45 degrees, and these are opposite angles of a cyclic quad. We have already seen that this is actually equal to 45 degrees there. Okay, by using a calculator, we're able to get the angle alpha in the previous question over here. Right, next we continue to look at more geometry questions. But now we are really saying if this is the given shape, a new circle is obtained when the given circle is reflected about the line y equals 1. Somebody reflected this circle about the line y equals 1. Right, we know very well that this is 3 and that is 5. So, and this is minus 2. So y equals 1 is this one because it is x and y. So y equals 1. So now this means that you can draw like this, so that you have y equals 1. So that in the end, you have the following. Right, so that if y equals 1, then we are able to find the coordinates of, right, the question 4.4.1. Right, so determine the coordinates of Q, the center of the new circle. Let's look at this one. Y equals 1 is this line here. You reflect this circle about the line y equals 1. What are the coordinates of Q, the center of the new circle? So if you reflect upon this line here, so you're going to have that the image is going to be somewhere here. This is here, but the mirror image is going to be somewhere here, and it's going to be Q. What are the coordinates of this? That is the question we are asking ourselves. Let's work it out. Right, so we have the following. Right, so we have the following. So if P has the coordinates minus 3 and 4, we want to find the image of this about the line y equals minus 1. And to find the image of this about the line, it must be the same distance. So you see, what is the distance here? So you must work it out and say, what is the distance here? From 1, y equals 1 and y equals 4, the distance is 3. The distance is 3 between y equals 1 and x and y equals 4. But x is going to remain the same if you reflect here, because it's just going to be rotated like that. So that now the coordinates of qx is going to remain the same because x is minus 3 here. So x is going to remain the same. I must apologize for the, there's a network issue there. I can see that, as said, you'll forgive me if you get cut because I'm going to make provision for the coming week so that we don't have such an issue. The distance between the line y equals 1 and y equals 4 is 3 units. So the distance now, the distance here between this line here, you must go down here away from the line, you must go down 3 units down. So if you go 3 units down, this is already 1. So you'd go like minus 2 units down. Okay, because then you have 2 units down and then 1 unit, which is 3 units, because the distance between the point and the line is 3 units. Also here, it must be 3 units. But if it's 3 units, this one is already 1 unit, right? If it's already 1 unit, then this one will have to be exactly 2 units, right? So that we have an overall required amount of 3 units. Right, this is 2 units and 1, which is 3. So, 2 and 1 is 3 units. 1 unit means that the distance from the x-axis to the line is 1 unit. But obviously, according to this, the distance between the line equals 1 and the point is 3 units. So that in the end, then what you're having is the coordinates of the point. The x is minus 3 and the y is minus 2. I hope that you guys are following there, which is minus 3 minus 2. This recording is going to be there. You'll try to make sense of it. Okay, if you reflect about the line y equals 1, if this is rotated to be directly below x at this point, x is minus 3, guys. So x is going to be the same because it's just rotated. It comes down, rotated like that, if you imagine. But the only thing is y is going to be such that to determine y is a bit tricky, as we said, because here you must work out the distance. The distance between the line and the point is 3 units. So you must, if this is the image, it must be 3 units as well. If this is 3 units, this is already 1 unit from the x-axis to the line. So you must have 2 units down, and 2 units below the x-axis will take you to minus 2 on the y-axis. Next thing, we're interested in determining the equation of the new circle. Equation of the new circle in the form that. So let us find this one. Right, to find the equation of the new circle, there's a couple of things you need to consider. So if this one here is the line y equals 1, and we know very well that this has the coordinates minus 3, minus 2. What is the equation of the new circle? Right, so we're looking at 4.4.2. The equation of a circle is x minus a squared, y minus b squared equals the radius squared. Okay, now take note of these. Here. So this is r squared. So that, okay, the center is this one. So the center is q with the coordinates minus 3, minus 2. AB, which means x minus into minus 3. Y minus into minus 2. Okay, then you're dealing with the radius. The radius. What is the radius? So you must deal with the radius of this circle. The radius of this circle becomes the distance. The distance between, right, because now we have a new circle that's obtained when it's reflected in the equation of the new circle with center Q. Okay, so the radius is obviously the same because it's the same circle. And we know that the radius was just the square root of 10 from the original question. And the square root of 10. And then if you have this, you square this radius. If this is the radius, you square it. So that this becomes x plus 3. Okay, it was given to be square root of 10, the radius of this circle. But if you put the equation, it becomes radius squared. It becomes radius squared. So radius squared will be, you just square the radius. So that, okay, you always put, the formula has x minus a. So if the center is minus 3 minus 2, you have minus minus, which becomes plus. And then you square here. Minus minus becomes a plus. And this is, you square the square root of 10 becomes that. Okay, try to think of this. I'm just sorry if we get cut there. and disconnected from time to time. So this is x plus 3, you square that, y plus 2, you square that in the, okay. I need to put a clear thing here, plus, a plus here, so that this is 10. Okay, all right. Right, the equation of the new circle is actually this one. It is the new circle with a center Q. The equations of the lines, okay, now we continue to look at the 4.3. 4.3. Right, in 4.3, we're looking at the equations of the lines drawn parallel to the y-axis and passing through the points of intersection of the two circles. Equations of the lines drawn parallel to the y-axis. Equations of the lines drawn parallel to the y-axis. Okay, yeah. We continue. We continue. We continue. Okay. What we want. Want the equations of the lines. Equations of the lines are given by y equals mx plus c. That is the formula for the equation of a line. Or if you don't want to write it like that, the equation of a line, I mean, that is the formula for the equation of a line. You can write it like that, or you can say y minus y1 equals what? M into x minus x1. This is the equation of a line. Okay. So this is what we have. So the equations of the lines drawn parallel to the y-axis, and passing through the points of intersection of the two circles. Let's do this. Here is the line y equals 1. If you reflect these circles, then what you're going to have is it's going to be sort of something like this. Yeah? Something like that. Okay? But obviously, I mean, this is not to scale. Let me try to draw something nicer. But it's going to be sort of this way. Equations of the lines drawn parallel to the y-axis and passing through the points of intersection of the two circles. Okay, points of intersection of the two circles. Okay, now let us look at these. So obviously at this point, what are the points of intersection of the two circles? Okay, the point of intersection, like the V point, we know that V has the coordinates -2, -1, but we need the other point. Right, so we need the other point. And so what are the coordinates of the other point? Right, so at the point at which these two circles intersect, what then are we able to achieve at this point? Right, so obviously you're able to see that you have the point V with the coordinates -2 and -1, -2 and 1, excuse, because y is 1. So it's -2 and 1. Right, so if it is -2 and 1, what then is are the coordinates here at the other point? So obviously now you need to work that out, but you have the two equations of the circle. What are the two equations? You have seen therefore that this one here was obtained as x plus 3 from the previous question. It was x plus 3 squared. X plus 3 squared, and then you have y plus 2 squared. And this is 10. That is the equation. So it therefore means a couple of things. I mean, it means that at the point that to find the points of intersection, right, of the two circles, a couple of things are very important. You already know the y. Y is 1. So you can put it there. So that you have x plus 3 squared. 1 plus 2 squared. Okay? And this is 10. X plus 3. You already know that the line that really intersects the two circles has the equation y equals 1. Okay, you repeat this question, guys. These questions, you repeat them, and during the week, I'm going to be bringing more mathematics, please. More mathematics, much more than this. This is 10. 1 plus 2 is 3. 3 squared is what? Is 9. Okay, so x plus 3 squared. What is 10 minus 9? It's a 1. The square root of x plus 3 squared. You apply the square root on the left, and then you also put plus or minus the square root on the right, which means that you have x plus 3 is plus or minus 1, which means x plus 3 is 1, or x plus 3 is minus 1, which means x, you have 1 minus 3, which is minus 2, of minus 1 minus 3, which is minus 4. Equations of the lines drawn parallel to the y-axis and passing through the points of intersection of the two circles. Right, so the equations of the lines, so, right, parallel to the y-axis, so parallel to the y-axis, they are vertical lines. So, you have that one of the lines is x equal to minus 2, and the other one is x equal to minus 4. X equal to minus 2 is one of the lines, and x equal to minus 4. So these are the lines, okay? Right? And these are the lines, x equals minus 4, x equals minus 2. These are the vertical lines. They pass through the points of intersection of the two circles, yet they are parallel to the y-axis. The y-axis is vertical, so the lines are also vertical, and we have found the equations. How did we do that? We substituted the y value, y equal to minus 1. You can substitute into any of the equations. I chose the equation here of this circle at the bottom. And this second at the bottom is x plus 3 squared plus y plus 2 squared equals 10. Right. Oh, guys, this has been awesome, awesome news. I must thank you for joining us this evening. I'm not going to be very long, but this is the last bit of the questions I planned. So I'm going to see you again during the course of the week. I'm going to keep you posted. We're going to go deeper into more mathematics. Get ready for more mathematics, but from us. And right now, this is enough for today. We must thank you so much for joining us, and have an awesome time ahead. I'm going to send the recording of this lesson, and also I'm going to send you homework. I've already sent Euclidean geometry homework, but I'm going to send analytical geometry or coordinate geometry homework on the WhatsApp group. And then I'm going to give you more instructions on the group. I need people to do the homework so that I can mark them. I need to mark for each person. But for you to do the homework, you must watch the videos first. Right. From us and tonight, right. Have a good evening and goodbye, everyone. Goodbye. Bye.